Okay, I've got the 4Z chart up for the evening of January 22nd, 2016. And if you'd like, if you don't have a copy of this chart already, you can stop the video and make a screenshot and analyze this if you like. You can analyze that and print it out. And I'm going to start doing a surface analysis on that because that kind of gives us a jump on the models right there by giving us, using actual data that exists, the actual surface data. So what I'm going to do is I'm going to do the isobars really quick first. Now if you're, I don't know if you're familiar with the values, but see this 008 here, this is sea level pressure in tens, units, and tenths. So this is going to be 1,000.8 millibars. On the other hand, this value right here, this is going to be 1010.5 millibars. So that's something you have to get used to when you're doing the analysis. I'm not going to get too much into that. I'm just going to get this analyzed. So what I'm going to do is I'm going to draw the 1,000 millibar isobar. I'm going to get something like that. So let me go ahead and label that, so that's pretty obvious. And what I like to do is I build this map up. I like to skip isobars because that gives me a much smoother and more accurate picture. So instead of going to 1004, I'm going to go to 1008. Maybe this will start making sense as I go. So 1008 is going to run kind of like that. Let me come up from the south here. We have to go all the way to central, start of the Florida Panhandle to pick up the 1008. So we're finding values of 080. So it's going to come in between this station and that station, but north through here. If I had a pen and paper, I could probably do a much smoother version of this. This isn't very easy to do with a mouse. You can see we're missing a lot of sea level pressure values in there, so we just have to do the best we can. We're going to come in between the 1010.5. There's the 1006.8. So we're actually going to do something like that. So let me label that very quickly. 1008 millibars. It's going to go in the middle right there. And there we go. You definitely want to label these as you go, as you do these hand analyses, because otherwise you'll get kind of mixed up. Then instead of doing 1012, we're going to do 1016. That's going to bring us probably up north of the window. 1016, see, we're looking for values of 160. Let me come up from the south. There's 1016. And I'm probably not going to go ahead and label all these because that's going to make the video take like another 2 minutes longer. I don't think you want to see the labeling, but this should be enough to kind of convey what values we're looking at. So we're looking for 1024 right there. 10. Now we're going to start filling in between the values. So we're looking between 1016 and 1024 to find 1020. In other words, 200. So that's going to look something like that. Then we go in between 1016 and 1008 to find 1012. So the value we're looking at there is 120. So it's a lot easier when you're in between values, so that kind of narrows down the stations you have to look at. Okay, we got a problem in here. We're going to have to kind of like wedge in on that. You don't want to like smooth, like you don't want to cut through here and draw the 120. You really got to stick to the field as closely as you can. So coming up from the south, it's going to look something like that. So by keeping these curves and stuff like that, that might be something you need to come back to later if you're trying to find a trough or a ridge or something like that. Those can actually be important. Then the only thing we're missing here is 1004. And for that one, we just come up from the south. There's 1004. Okay, so 1004. And I'm going to look for another closed low out here and find a kind of a weak one here around Asheville. So there's 1004. That's going to be a low pressure area. And let's go off the coast. Do we have any 996s? We're looking for 960. Well, I find 939 right there, so that's a candidate right there. I don't really find anything else. There's 965, so I might be able to extend this isobar a little bit offshore. Well, there's 927. I can't quite do that, so I'm kind of... Oh, I'm doing 996. I'm sorry. Yeah, so yeah, we do want to pull that south. 996, this is cyclonic flow in here, so this wind right here along the barrier islands. 961 is blowing into lower values, so we're going to bring that northwest of that plot right there. So you see what we did right there? So where's the low pressure area? Let me make a symbol here to kind of keep things looking neat. There's L for low pressure. We'll drop this one over Asheville. But the one off the coast, we're going to pinpoint that right there. So you see that flow coming up from the southeast? That's spiraling into that low, up and to the west. And out behind it, the flow is coming in from the northwest towards the southeast and then curves into that low. So that low is right there in that bay. I don't know exactly what the name of that area is, but that's where the low is. And now that we've got that pinpointed, it's just a matter of finding the fronts. We'll switch to blue to find the cold front. Don't have much to go on because there's not much offshore data. But we got this one plot here of 68 degrees and strong southeast winds. And here it becomes more westerly and cooler. So we're probably looking at, I don't know, maybe further south, kind of like that. This is where radar can help. We can look offshore and try to find like a squall line corresponding to that. So maybe something like that is what we're looking at. Can also look at satellites sometimes. And then the warm front. Warm front, we got a warm 62 right there on the Berry Islands. Kind of contrasts sharply with this sub-freezing air inland. This is that flow of warm air coming in from the southeast. Look at that, 66 offshore. Try to do that again. I did undo and it took off my fronts, so I'm going to have to draw the cold front again. So let me sketch that in very quickly. Messed up again, getting some system lag here. Okay. And then the warm front is going to go something like this. And we'll draw the pips on for the warm front. It's going to look kind of like that. And then for the cold front, we'll draw the barbs on like that. And since we don't have a pressure field out offshore, we can't really extend the isobars out here. It's not, that's just one of the conventions of analysis. You don't draw data where there's no data. The computer forecast can do that, but we can't really do that. But there is some actual data out here. See that 970? So let me take this 1000. Let me extend that. Kind of capture that warm front right there. This is getting very sketchy, but we can probably go ahead and do something like that. And then for the 996, we'll take that, kink it along that cold front, bring it north, and there we go. So this is pretty good considering we're just doing this with a mouse like really quickly. But now you can take that and compare that to the high resolution rapid refresh model, or the even the WRF if you have a 03Z forecast or 04Z, and you can see if the model is running too close, or I'm sorry, too fast or too slow. All right, let's see what else is going on. Now we can start looking at the precip field and see what's going on there. We do know that we're getting the warm sector streaming north, and that's overrunning the cool air. So we're getting a lot of lift here from Norfolk up to Roanoke and up to the Maryland, Delaware area. So this is the area we're concentrating on right now. The area to the west in the Carolinas is starting to become more under cold air advection. So you can see the precip is starting to taper off in that area. Kind of a quick system that moved through there. Let me draw the precip areas real quick. That'll give us a rough idea of where we're getting the sustained low and mid-level lift. Of course, over the Appalachians, orographic processes are a factor too. So there we go. See that? We're kind of outlining the area of precip. Basically anywhere from Columbus, Ohio, down to Frankfurt, down to Nashville, and points eastward. They're the ones getting the precip. Down to the south, probably convection along the front. And back here, we're starting to get like some of that dry slotting, and cold air advection is not a very significant precip process, so not a whole lot going on back behind it. But we do have the upper level low. That's probably what the surface low corresponds to. That's providing a whole lot of instability back here. So we're seeing some showery type activity there in combination with lift over the mountains, the Blue Ridge Mountains out in that area. Further to the north, well, freeze line is running from about south of Dover Air Force Base down to south of Roanoke and sweeping into, I don't really know the cities here all that well. I'm coming up blank there for cities in this area, but anyway, there you go. There's the freeze line. You can still have snow south of the freeze line, certainly, but you're not going to get quite as much accumulation. North of that, we're getting kind of the mixed phase precip in through here. If we looked at the polarimetric radar, we could really learn some stuff there. I might do that if I have time later.